Okay, so thank you, Marco. Good afternoon, everyone. So I hope everyone is listening loud and clear. If you have problems, use the chat box. So as usual, and like Marco said, I will talk about the current weather situation, and my colleague Bruno will talk about some past events. But before, as always, I like to know where you are at this moment. So please use the mark or arrow on the map. You already know how to work with this. So this is the map, the forecast for today in Portugal. We have sunny weather. We still have are experiencing some summer. 26 degrees maximum temperature for today. Of course, we cannot compete with the 37 in Dubai, as I saw in the chat box. And okay, so most of you from Central Europe, Eastern Europe, and of course, Andre is in Dubai. Sorry about this. And some in the Northern Europe also. Okay, so let's continue. Thank you, everyone. So I want to show you this picture. It's a large picture because, of course, we have here the main three important systems. They are almost on the borders of the image. And that's why it's quite large. So it has almost North Atlantic and all Europe. And we have here. So I'm going to start to show this. This is better. This one here, we have this is the post-tropical cyclone Odette. It's still a deep cyclone, and over this we have some troughs that have some cloudiness. Yesterday the cloudiness were more compact and with some convection. But these systems cannot move east because of the reach over the Central Atlantic, and it's blocking the systems going further east. We have over Iceland, so let's first clear this. We have over Iceland a deep low that is traveling fast and has a frontal system that will affect Iceland and Norway today. So these systems, both this one and this one, have associated some persisting in this area, persistent strong winds. And these are generating some waves, some high seas, and the waves are going to propagate towards northeastern Europe. Mainly, this area over here is going to have some high waves in the next few days. Okay, moving to this system over Europe, we have this one. We have some lows over here, so we have this cutoff low over France, and this large area covering almost all eastern parts of Europe. And we have, I will clear my annotations. We have here this little one here, northern of Croatia. It's a law that yesterday brought some severe weather over northern Italy. And these systems over Europe will bring some kind of severe weather, such heavy rain, winds, and chances of thunderstorms. Not shown in this image, but there are also two active tropical cyclones further south, the tropical storm Peter and tropical storm Rose. So let's continue. Checking the upper air dynamics with the water vapor 6.2 image, with both maximum winds and geopotential at 300 hectopascal. And here we can find the position of the jet stream and possible areas of turbulence, which is important for aviation. We can check some moisture and dry boundaries. That could be areas of convection initiation. And also, but with the help of the previous RGB, areas of dry descending stratospheric air. So we have over here this area with some turbulence. We also have the areas of dry air. This one here. We have this one here that is areas of concern. Some areas in here, and also this one that could be areas of convection initiation and severe weather in the next hours during the day, during today. So we also can evaluate how deep is the convection using this 10.8 enhanced. And near the system south of Newfoundland, there is a line of deep convection, this one here. And this is associated with a cold front or a convergence zone south of this low pressure system. And of course, over South Europe, the areas related to those low pressure systems are still areas with some convection, mainly from yesterday, but we still have over northern Greece at 3 UTC. This is images from 3 UTC, and you can see that we still have convection during night. So with the help with nowcasting south lifted index, which is very good for pre-convection. So we evaluate the areas of instability. At 3 UTC, we have mainly the Mediterranean Sea with low values of lifted index. So the areas where the unstable air mass is more areas of unstable air mass is over Mediterranean Sea. But of course, with during afternoon, these areas of instability can go further inland, and we have possible of convection. This is a model product that is for today. This is from ECMWF, and it is a very good tool to check the areas where ensemble system expect anomalous weather to occur. So it compares the ensemble distributions with the model climate, and as I said before, we have these areas over here, mainly for marine purposes. We have heavy rain, heavy strong winds, and of course the generating waves. And we have here these yellow colors that it means a warm advection. So this area is important to monitor, mainly for marine purposes. We also have this area of strong winds near coast of Portugal. This is a large area, go further south until just reaching Madeira Highlands. And of course, related to the low pressure system over Europe, we also have cold advection, so cold air. We have rain and wind. And also, if you see over southern Europe, we have a small areas of heavy rain or possible heavy rain, and this may be related to local convection. So this is a good product to have like an overview of the severe situations or expected severe areas throughout the day. So we checked the upper levels, but also we need to see what is happening at surface level. And at 6:30 UTC, I had to use 2 RGBs. So on the right side, we have the natural color RGB, and on the left side, we have the night microphysics. And I want you to notice this large area here, mainly this area here. It's the whitish area. It means low-level clouds, water clouds. And so in these areas, we have a possible fog. And of course, the main hazards, we can say it's rain or drizzle. But of course, we approach the low pressure system, and we also have more thick cloudiness, and with some high level clouds. There are bluish clouds, and in these areas, of course, we can expect most heavy rain. Of course, it's more moderate or heavy rain. Over the Atlantic, so over the Atlantic here, we can have the typical stratocumulus associated to the high pressure system. And over this area here, we have this red thick cloudiness that are related to those systems I previously talked about. And I'm going to talk a little bit more about this system over the south of Newfoundland. So this is the remnants of tropical cyclone Odette. It is at the moment it is south of Newfoundland. And this is a Cloud Phase RGB that is goes east and will be available with the new MTG satellite. This RGB will be very good at discriminating cloud particle size because of the new channel, the near infrared 2.2, and cloud phase because of the new near infrared 1.6. So they are used together because of this. So it will be a good RGB for cloud microphysics. So let's focus on this area within the white square, which is the remnants of Odette. So in this area, we can see some examples of thick ice clouds. They are blue, with the major contribution of the blue beam. And we have the difference between the light blue and the darker blue. So the light blue are small particles, and the large particles are in the darker blue. An example of the pinkish area, so these are thick water clouds. In this case, they are mostly pink, so we are facing some large droplets. So continue with this remnants of Odette. So this is the last update from National Hurricane Center. It shows the tropical cyclones, the Peter, Rose, the tropical storms, Peter and Rose, and some disturbances that they are from over the Atlantic. And you can see here that maybe former Odette will acquire some tropical characteristics with a 30% chance in the next 5 days. So he's moving he is southeast. As I show you, the ridge is tropical, subtropical ridge is blocking the movement, so he's moving southeast and is going to warmer water, so it may acquire tropical or subtropical characteristics. So this system is Azores is monitoring this system very carefully, but also Rose. So Rose here. So Rose here, it's this tropical depression. Also have a trajectory, a forecast trajectory, more or less like this, and then slightly like this. So it's also in a long range. It's also a system that we still have to monitor. And now to show you what ECMWF forecast for this system. As you can see, the ensemble trajectory is quite uncertain at this point, and the ECMWF ensemble system does not know where will be the trajectory of this system. It's quite confusing in this area also. So Azores islands are really near, so we have to keep a close monitoring for this system here. Well, my last slide. So yesterday, you know that the volcano Cumbre Vieja, I hope it's well say. So the volcano erupted in La Palma yesterday, early in the afternoon, and the volcanic ash RGB, it's a very good RGB to monitor the volcanic plume. So here we have in the light green, we have the SO2 gas plume. And this SO2 gas plume is detectable due to its absorption band at infrared 8.7. And it appears green, like in these images. So 3 images from yesterday. The first one, top left, it is the first one, I think. The first one I could see the SO2 gas plume, and the last one, it was from this morning, 6:45, and we have a larger plume south of La Palma, sorry. So this is this RGB, it's very good because it works day and night. The SO2 gas plume has a good color contrast against ice clouds and surface features, but depends on the satellite viewing angle. So for high satellite viewing angles, we should use the dust RGB. It's more appropriate. Also interesting, it's this volcanic ash RGB, the dust RGB and the 24-hour microphysics RGB. They all have the same channel combination, but be careful because they have different ranges and or different gamma corrections. So this is my presentation, my last slide. Thank you all, and now Bruno will start.
Hello, good afternoon. So, welcome. Let me just start. So I'm talking about a low that was generated on the other side of the Atlantic Ocean. It was predicted to reach the western coast of the Iberian Peninsula around mid-September. And here you can see the water vapor image for the 10th of September, superimposed by the 300 hectopascal geopotential. And the forecast predicted its evolution to southeast in the next 48 hours. We use, and you can see here the scattermeter observations from the Chinese satellite and from the METOP satellite. And with these observations, it was possible to follow the location of the center of the low near the surface, as it was clearly visible in the cyclonic winds. Then, early on the 13th of September, the low was located west from the Iberian Peninsula. Here, also the water vapor and the geopotential at 300 hectopascal. And providing some fuel to the presence of the low, there was a very long period of time with a typical absence of northern persistent winds near the western coast of Portugal. And these northern winds that didn't happen are responsible for the upwelling and consequent lowering of the sea surface temperature. And here you can see the SST and the SST anomaly obtained through now the state of the ocean site. And as you can see, the anomaly is 2 to 3 degrees higher than it was normal on these periods. And here through NASDIS, we can see the composition of images for the 14th of September. It shows the merged total precipitable water product, and is generated by several sensors, and is showing the integrated amount of water vapor in vertical column in millimeters, and it's very helpful in forecasting heavy rain events and floodings. On the bottom, we have TPW anomaly showing above average values near the Iberian Peninsula. For the 13th of September at 6 UTC, we have here on the right, we can see the 10.8 channel superimposed with the enhanced layer, showing cold tops and as convection initiates near the coast, and you can see here clearly a V shape. Also, we have the SMWF taphogram model forecast that shows high instability in all troposphere layers above the layer of near the surface. Here we have some cross sections. On the top right, we have the air mass RGB and the isotex at 300 hectopascal level. And after making some vertical cross sections, you can see that on this upper left corner, the cross section comprised with equivalent potential temperature and relative humidity, showing here a cold front with low values of relative humidity to the left, and here with the equivalent potential temperature showing a cold front. On the low left corner, you can see the equivalent potential temperature with wind, and the location of the jet streak here. And on the right, we have the vortice advection showing positive values near or left to the jet streak, and somewhat similar to the intensification by jet streak with the left exit of the jet streak, providing some fuel to the convection. So on the first day of the 13th, we had over 57,000 lightning observations in the IPMA lightning detection network, with the highest accumulation of precipitation in 24 hours being around 90 millimeters. The precipitations were mainly accumulating in 2 hours throughout the country, and with many floods being registered. Most of the observations were around 30, 40, 50 millimeters in 2 hours. On the left, we have a taphogram constructed with the data from the sounding balloon from Lisbon at OVTC, showing some instability in mid-levels and some moisture content also. Then checking the humidity and instability projects of the SAF nowcasting on late 13th, we could see in cloud-free areas the amounts of precipitable water detected above 30 millimeters, and also relevant values of the K index, a measure for thunderstorm potential, and the lifted index, a measure for atmosphere instability. Here is 14th of September at 6 UTC. You can see also the 10.8 channel superimposed with the enhanced layer, showing cold tops and convection in the overland. Also making some vertical cross sections. We can see on the upper left corner the cross section comprised with the equivalent temperature, also under relative humidity, with also low levels at the left and higher levels of humidity to the right. On the bottom left corner, we can see also the equivalent potential temperature and vorticity advection, showing positive values on the upper part. And on the bottom right, we have here with the convergence, so showing mostly convergences at lower levels and divergence in higher levels. So this is somewhat similar to the NS cumulus conceptual model. On the second day, we had over 49,000 lightning observations in the IPMA lightning detection network. Highest accumulation of precipitation in 24 hours, around 80 millimeters. Precipitations were also mainly accumulated in 2 hours, and particularly in the south of the country, with many floods being registered there. On the left, we have also the data from the sounding balloon for Lisbon at 12 UTC, showing less severity than the day before, which was not the case further into the interior of mainly from the south region. Overall, there were 2 days, so 13 and 14, marked by intense precipitation leading to flooding, frequent lightning activity, as you can see here. And the third day, the 15th, was characterized by punctual never precipitation, but with no lightning or very few lightning. So then to finish, I'll show you some images from a rest situation in mid-September, with heavy snowfall over Greenland due to the passage of the Hurricane Larry, southeast of Greenland. Of course, when it passed there, it was no more the hurricane, it was a post-tropical storm. And on the left side, you can see the National Hurricane Center prediction of the path. This is for 3 days, a forecast made at 9 of September. And on the right, we have a map with the snowfall amounts represented by a GOS model. They are shown in millimeters of water, and is accumulation for 12 of September. And the model shows an area around 50 millimeters of water, which is equivalent in this product to about 200 millimeters of snow. We took a look at the GOS. So we look at the GOS 16 or GOS East, and you can observe the land-filled snow. Here we have Greenland. And on left side, so we have this geocolor product, which is an approximation of the daytime true color. And here there is no discrimination between clouds and snow. They are very similar. And on the right side, we have the day snow fog RGB that shows a great contrast between snow and clouds. And just to finish, we have here the recipe, and you can see the channel 1.6 helps immensely in distinguish cloud from snow, with low contribution for snow and high contribution for clouds. Also, the difference in the blue helps in obtaining this day snow fog RGB made from GOES satellite channels. So thank you very much. We end here with two RGBs from the left one from dust and the right one from the HRV cloud RGB over La Palma, and you can see that in both of them you can see the plume that Angela already showed at the dust RGB. Thank you.